Alright guys, I just want to make a quick video about Exploration 7.2. Sorry it's been a long time coming, but I know some people had some trouble on it, so I want to go ahead and just show you how to work it out. So the whole point of this exploration is really just to get y'all introduced to experimental probability. So that means like actually carrying out an experiment and seeing the outcomes. And then next week what we want to do is we want to compare our experiments, right? So what we did in practice to what should happen mathematically. So as you recall in 7.1.1, me and coach were unable to finish our game because of the coronavirus. And so we asked y'all to think about a fair way of how we could divide up the pot. A lot of y'all submitted some really, really good answers in the Google form, so thank y'all for that. Some of the favorites that I heard a lot were just to divide it halfway or to give it more to Coach De Leon than Mr. Bustamante based on some percentage based on the amount that they won. So you guys already had a good idea there. So thank y'all for participating. We're going to continue this game today. So we have the results from our 15 FIPS. Question number 1 says, using a coin, complete the game by flipping the coin until a winner is determined. So you don't have to use all the rows. So let's look at the standings right now. Let's see. I have 6 points. Coach De Leon has 9 points. So what that tells me is if Coach De Leon gets at least 1 point, he's going to win. So if we flip the coin and we hit a tails, we can stop. So I have my coin here. I'm going to flip it. And I got heads. So that's a heads. Let me write it. That means I have to keep flipping. And now I'm up to 7 points, right? So we're at 7. So we flip again. And it was tails, unfortunately. So tails. That means coach is at 10 points. And we can stop there. The reason why we can stop is because he already won the game. So coach won. So coach De Leon. Right. So that's all you have to do on your own. So if you want to do it, you can copy my experiment, or if you want to flip your own coin and decide, go ahead and do it. So question 2 says, even though a winner was determined in problem 1, do you think it's fair to decide the outcome based on one experiment? Now me, I'm going to be the advocate for saying no. The reason why is because I think I could get lucky. Look, I got lucky and got a heads. And then if I look at my data, look, sometimes you got like 4 tails in a row, right? Or 2 heads in a row or something like that. So in my eyes, I can totally get 4 heads in a row and win. So I'm going to say no, I don't think we should just decide it on one trial. No. We would need more. Because anyone can get lucky, right? Anyone can get lucky. And what I mean by that is, again, like we have these instances where we have multiple heads in a row, multiple tails in a row. So if I were to get lucky and get multiple heads in a row, at least 4, I would win the game. Okay, so hopefully that helps you out with that one. Question number 3, it says, based on your answer in problem 2, what could we do to make the outcome of the game more accurate? So, well, if instead of just using 1 trial, maybe 100 trials, right? 1,000 trials. How many trials would we do to make it perfectly fair? Maybe infinite trials, right? Is that even possible? Is it possible to do infinity trials? Well, we can, right? I even think you could do a computer simulation that might do that, and it'll go on forever and ever, but it'll never stop. So this is getting us to start thinking about, well, how do we get this infinite trials, right? Because if 100 trials or 1,000 trials is good, how do we get infinity trials to make it perfect, right? So let's keep that kind of in the back of our head. And we're going to move on to question number 4. So question 4 says, go ahead and carry out the experiment 20 times. Repeat the problem in 1, basically. So I'm going to just repeat it until we have a winner. So I'm going to pause the video, and I'm going to flip my coin, and then I'm going to unpause the video and write my answers. So what I would like y'all to do is y'all do the same thing. So repeat what we did in problem 1. Flip your coin. You're going to do this 20 whole times. You're going to complete the game 20 times so we could get some good data, all right? So go ahead and do that. Pause the video and go ahead and do that. Okay guys, so I went ahead and completed my trials. Here they are. Boom, 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 boom. If you want to look at them real quick, you can see that Mr. Bustamante, only won once, twice, and that was it. The rest of those 20 trials were won by Coach De Leon. So 18 for De Leon. Let me write that in pen here. 18 De Leon, and then 2 for Bustamante, just so we have that later. So I flipped the coin. That's what I ended up with. And ask yourself, does that make sense? Why? Why does that make sense? I mean, it's a lot easier to just get one tails than to get 3 heads in a row, right? So I think that makes perfect sense. That our results are pretty good there, for that experiment. So I think we conducted a pretty good experiment there. If you got something a little bit different or off, that's 100% okay. These are experiments, right? They're gonna differ from trial to trial, person to person. So based on our experiments in problem 4, let's move on to problem 5. It says, Mr. Bustamante won how many games? Well, I won 2 games, right? Out of the 20. Mr. De Leon won 18 games out of 20 whole trials, right? Because we played the game 20 times. So based on our experiments for question 6, it says, what's the win percentage of Bustamante and De Leon? So we're going to use this little formula here. It says games won divided by total trials times 100. So for Bustamante, that would be 2 divided by 20, which is equal to 0.10, and then times 100, which is equal to 10%. So his win percentage is 10%. Now we could use the formula, or knowing how probability works, we could be smart and we could say, well, if I'm 10%, how much does Mr. De Leon have to be? What do you think? Well, he has to be 90%, right? Because both of those have to go ahead and add up to 100%. So it says we're going to use this based on our experiment, and we're going to figure out how much of the $1,500 each teacher should get. So what I'm going to do is I'm just going to multiply the percentage times the pot amount. So for Bustamante, that's 10% times $1,500. If you don't have an Nspire handy, you can just do 0.12 times 1,500 in your phone, and you should get $150. Now again, you can do this calculation, or you can be smart and say, I know that there's $1,500. If 150 of that has been used, then I only have $1,350 left for Coach De Leon. Right? So how do these results compare to your judgment in 7.1.1? That's going to be for you to figure out, right? Because it depends on how you answered. If you said split the pot down the middle, you can obviously see that this very much disagrees with that, because I should only be receiving $150, while Coach De Leon should receive a majority of the amount, right? So just think, do y'all think this is pretty fair? To me, I think this is really fair, right? But that begs the question, how can we make it even more fair, right? How can we further better the accuracy of our conclusions here? What if we tried infinite trials? What I mean by that is, what if instead of just doing 20 like we did up here, we go on forever and ever and never stop? Wouldn't that be the best way to figure it out? But then you got to ask yourself, well, if I never stop, how do I figure out the winner, right? Or how do I figure out when to stop if we're doing infinite? Because infinite never stops. It's pretty good questions, right? So pretty good questions that we're going to answer in the next exploration. So hopefully this exploration, it just kind of helped y'all guys get an idea of experimental probability and how it worked. See y'all next week.